Welcome to the lecture number 8 of video lecture series of Engineering Mathematics 3 of Laplace transform. So, in previous lecture we have started the second shifting property and also we have seen some examples on that. Now, today we are going to start the third property, that is property number 3, change of scale property. Change of scale property. What is this change of scale property? This is very simple property. Okay. So what is exactly this? Let us see. If Laplace transform of f of t is equal to f of s, okay, that will be given in the question, then Laplace transform of f of at, okay, that means here the scale has changed. Here you know the Laplace transform of f of 1t, that is f of s, and if you have to find the Laplace transform of f of at, then how to write this? Then 1 upon a into f of s upon a. This is the formula for this change of scale property. Now how to simplify this? Let us see. So let us see example number 1. Very simple properties are there. Find Laplace transform of f of 4s. Find Laplace transform of f of 4t. 4t if Laplace transform of f of 1t is given 4s upon s square plus 2s plus 1. Okay. So what is given here? Laplace transform of f of t is given to you, and what you have to find out? Find Laplace transform of f of 4t. Now here by using this particular term, you can understand that we have to use change of scale property. Okay. So how to do this? Let us see. Solution. Given Laplace transform of f of t is given. So what is that? That is given 4s upon s square plus 2s plus 1, isn't it? So now by using change of scale property, Laplace transform of f of 4t, so the value of a is 4, so 1 upon 4 into, okay, 1 upon 4 into whatever this f of s is given, that is 4s upon s square plus 2s plus 1. So just replace this s by s upon 4. This is the meaning of this change of scale property. So now 1 upon 4 as it is in bracket. So 4 in bracket s, in place of s what we have to write down? S upon 4 divided by s upon 4 bracket square plus 2 into s upon 4 plus 1 bracket close. Okay. So now that is equal to this 4 and this 4 get cancelled. What we get here? This 1 upon 4 as it is. S upon, here if you solve this, s square upon 16 plus 2s upon 4 plus 1. Okay. Now if you can here further simplify by taking the LCM. So this 1 upon 4 as it is in bracket, the LCM of this will be, okay, this s as it is divided by the LCM of this 16, 4 and 1 is 16. So how to simplify this? If you divide this this 16 by this 16, then 16 by 16 is 1, and whatever answer will be coming, to that answer we have to multiply by this numerator. So a square into 1 will be a square plus 16 divided by 4, that will be 4. So 4 into 2s, that is 8s, plus here 1, 16 divided by 1 is 16, 16 into 1 is 16. Okay. So this 16 will be at the numerator. So 16s divided by this 4 as it is, s square plus 8s plus 16. Okay. Bracket close. 4 1s are 4, 4 4s are 16, and final answer will be 4s upon s square plus 8s plus 16. So this is Laplace transform of f of 4t. Okay. So in this way we have to solve the numericals. Okay. So this is very simple method. There is no any complication in this particular method. So I hope you understand this, and I will give 1 to 2 examples for homework, and after that I am going to start the next property. Okay. So example for homework, example number 2. If Laplace transform of f of t is equal to s square upon s cube plus 2s plus 1, find Laplace transform of f of 2t. Okay, simple example. And one more example. If Laplace transform of f of t is equal to s upon under root s square plus 1, find Laplace transform of f of 2t. Okay. So these are the two examples which are very simple examples. Just by seeing that example number 1, you can able to solve these examples. Okay. So I hope you understand this property, change of scale property. Now let us start the next important property, that is property number 4. Property number 4. This is very important property, that is known as multiplication property. Multiplication property. This is very important property. Okay. So now what is this multiplication property? Let us see. If Laplace transform of f of t is equal to f of s, okay, then Laplace transform of t into f of t, okay, Laplace transform of t into f of t is equal to, this can be written as -1, okay, into d upon ds of f of s. What is this? Look at this. This is very simple property. Laplace transform of t into f of t is equal to -1 raised to 1 into d upon ds of f of s. In short, Laplace transform of t raised to n into f of t. That means what? If in the multiplication of f of t, if there is t raised to n, okay, that is known as multiplication property. Then how to write this? -1 raised to n into d raised to n minus 1 upon d upon ds raised to of n minus 1 into f of s. Okay, sorry, d raised to n directly here, sorry, d raised to n upon ds raised to n. That means if there is a power of n, t raised to, if the power of t is n, then what we have to do? We have to take here nth derivative of that particular f of s, whatever we have calculated or whatever is given. Okay. So this is the formula for the multiplication property. Okay. I will write this separately. Laplace transform of t raised to n into f of t is equal to -1 raised to n into d raised to n upon ds raised to n into f of s. Okay. Remember this. Now let us solve example on this, and after that you will understand easily. Let us see example number 1. Find Laplace transform of t into sine of 2t. Okay. Find Laplace transform of t into sine 2t. So how to identify that this example is of multiplication property? So look at this. This is your f of t, and in multiplication of this f of t there is t. Okay. So in this way we can identify the type of example. Okay. So now to solve this, let f of t is equal to what? First sine 2t. Now take the Laplace transform. Laplace transform of f of t is equal to Laplace transform of sine 2t. Okay. So what is Laplace transform of sine 2t? 2 upon s square plus 4, and this is your f of s. Now by using multiplication property, okay, after that what we have to write? By using multiplication property, Laplace transform of t into sine of 2t is equal to minus 1 raised to 1, that is here the power of t is 1, so that's why 1, d upon ds of f of s. So what is value of f of s? 2 upon s square plus 4, just we have calculated this value, okay. So now that is equal to minus 1 as it is, okay. This 2 can be taken outside, or if you can put it as it is, 2 upon s square plus 4. Now if you want to solve the derivative of this, then you should be able to remember the formula of derivative, that is d upon dx of u by v. So what is this formula? V as it is du by dx minus u as it is dv by dx upon v square, okay. So by using this formula of derivative, you have to use this formula here, and after that you can able to solve this. So this is u and this is v. So this can be written as minus 1 as it is into v, that is s square plus 4 as it is, into derivative of 2 is 0, minus 2 as it is, derivative of this s square plus 4, derivative of s square is 2s, but derivative of 4 is 0, isn't it? Divided by v square. So s square plus 4 bracket square bracket close is equal to, so this is minus 1 bracket, this 0 into anything 0, minus 2 to the 4s upon s square plus 4 bracket square bracket close, okay. And finally this can be written as minus minus plus, so 4s upon s square plus 4 bracket square, this is Laplace transform of t into sine of 2t, okay. So this is the answer, okay. So this is very simple, isn't it? Now again there are some examples for homework, so try to solve this example at home. Example number 2, find Laplace transform of t into cos of 2t, okay, simple example. And example number 3, find Laplace transform of t into sine square t, okay. So what we have to do? We have to use Laplace transform of sine square t. Already we have solved such type of examples in type number 1, okay. So use that and try to solve. Next example, find Laplace transform of t into cos square t, okay. So try to solve these examples, and in next example we will see how to solve the examples containing t square and more than t square, okay. So I hope you understand the two properties, that is for change of scale property and multiplication property, which we have covered in this lecture, okay. Thank you very much. In next lecture we will see the next property and some more examples on multiplication property. Thank you very much.